Mars, often called the Red Planet, is the fourth planet from the Sun and has fascinated humanity for centuries due to its striking appearance and similarities to Earth. Here are some key facts and highlights. Nash 1. Physical characteristics. Color. Mars gets its reddish hue from iron oxide on its surface, which covers vast desert plains, valleys, and mountains. Size. It's about half the size of Earth, with a diameter of around 6,779 kilometers, 4,212 miles. Gravity. Mars has about 38% of Earth's gravity, meaning a person weighing 100 pounds on Earth would weigh only 38 pounds on Mars. Temperature. The planet is generally cold, with average surface temperatures around 80 degrees Fahrenheit and 60 degrees Celsius, although they can vary from -195 degrees and 125 degrees at the poles to 70 degrees Fahrenheit, near the equator in the summer. 2. Geography and topography. Olympus Mons. Mars is home to Olympus Mons, the tallest volcano and largest shield volcano in the solar system. Standing around 13.6 miles, 22 kilometers high, it's almost 3 times the height of Mount Everest. Valles Marineris. This massive canyon system stretches over 4,000 kilometers, 2,500 miles, and plunges as deep as 7 kilometers, 4 miles. It dwarfs the Grand Canyon, making it one of the largest known canyons in the solar system. Polar ice caps. Mars has polar ice caps composed of water ice and frozen carbon dioxide. These caps expand and shrink with the Martian seasons. 3. Atmosphere and climate. Mars's atmosphere is thin and primarily composed of carbon dioxide, about 95%, with traces of nitrogen and argon. It's about 100 times thinner than Earth's atmosphere. Because of this thin atmosphere, Mars lacks a substantial greenhouse effect, which contributes to its colder temperatures. The thin atmosphere also provides little protection from the sun's radiation, making conditions harsh for potential life as we know it. 4. Water on Mars. Past water evidence. Strong evidence suggests that Mars had liquid water in the past, with rivers, lakes, and possibly even oceans. Features like dry riverbeds, lake beds, and mineral deposits hint at a wetter, possibly more habitable past. Present water. Today, water on Mars exists mostly as ice in the polar caps and beneath the surface. Some liquid water may exist transiently in briny forms during the warmer seasons, but it's still a topic of ongoing research. 5. Seasons and days. Mars has seasons similar to Earth's because it has a similar axial tilt, 25.2 degrees compared to Earth's 23.5 degrees. However, because Mars takes longer to orbit the Sun, its seasons are almost twice as long as those on Earth. A day on Mars, known as a sol, is approximately 24.6 hours, only slightly longer than a day on Earth. Nahasher 6. Potential for life. Although no definitive evidence of life has been found on Mars, the discovery of water ice, seasonal methane emissions, and organic compounds has made Mars a prime target in the search for microbial life. Robotic missions, such as the Mars rovers, Curiosity, Perseverance, and Orbiters, are investigating Mars's surface and atmosphere to find clues about its potential to support life, past or present. Number 7. Human exploration and colonization. Mars is considered the most viable candidate for future human exploration and possibly colonization due to its proximity, day length, and the availability of water ice. NASA, SpaceX, and other space agencies are actively working on plans to send humans to Mars, with potential missions projected for the 2030s. These missions would aim to establish a long-term human presence, with the hope of one day building sustainable habitats. 8. Robotic exploration. Mars has been the most visited planet by robotic missions. NASA's rovers, like Spirit, Opportunity, Curiosity, and Perseverance, have explored different regions of Mars, providing invaluable data on the planet's geology and climate. The InSight lander is studying Mars's interior, while Perseverance is collecting samples that a future mission may return to Earth for further study. Mars holds keys to many mysteries about planetary formation, evolution, and the potential for life beyond Earth. Each new mission adds another piece to the puzzle, making Mars one of the most compelling places for scientific discovery. Sure, Mars has even more intriguing features and mysteries that make it a fascinating subject of study and exploration. Here's a deeper look at some additional aspects of the red planet. 1. Mars' atmosphere and weather patterns. Dust storms. Mars is known for its massive dust storms, which can engulf the entire planet. These storms can last for days, weeks, or even months and significantly impact temperatures. Dust storms on Mars are caused by solar heating, which warms the surface and causes winds that lift dust into the atmosphere. Carbon dioxide frost. In the colder Martian winter, carbon dioxide from the thin atmosphere can freeze and form a layer of dry ice. This frost is particularly prominent around the polar regions, where it creates a seasonal ice cap. Methane mystery. Mars has mysterious methane plumes that appear and disappear seasonally. Methane is significant because on Earth, it's primarily produced by biological processes. Scientists aren't sure whether Mars' methane is a result of geological activity or potential microbial life below the surface. 2. Martian moons, Phobos and Deimos. The larger of Mars's two moons, Phobos is heavily cratered and appears to be spiraling slowly toward Mars. In about 50 million years, Phobos is expected to crash into Mars or break apart to form a ring. Deimos. Smaller and farther from Mars, Deimos orbits more stably. Both moons are irregularly shaped and are thought to be captured asteroids from the asteroid belt or remnants of an ancient Mars-Moon collision. Future exploration. Japan's space agency, JAXA, plans to send a mission to Phobos in the near future to collect samples and return them to Earth, which could provide insight into Mars' history. 3. Mars' magnetic field, or lack thereof. Mars currently lacks a global magnetic field, unlike Earth. However, there is evidence that Mars once had a magnetic field billions of years ago, which would have helped protect it from the solar wind. The loss of Mars's magnetic field is believed to have contributed to the erosion of its atmosphere, as solar winds stripped away lighter elements. This process might explain why Mars transitioned from a potentially habitable environment with liquid water to the dry, cold desert we see today. Remnant magnetism. Although Mars lacks a magnetic field today, ancient magnetism is preserved in parts of its crust, indicating areas that were once magnetized, which researchers use to understand Mars' geological past. 4. Ancient Mars and the potential for oceans. Evidence suggests that Mars may have had vast oceans and lakes about 3.5 billion years ago. Some scientists propose that an ancient ocean once covered the northern hemisphere, known as the hypothetical Northern Ocean. These bodies of water would have required a thicker atmosphere to exist, which Mars likely lost over time. Traces of river valleys and deltas suggest that water once flowed across the surface, carving the landscape and possibly supporting microbial life. 5. Perseverance rover and the search for biosignatures. NASA's Perseverance rover, which landed in Jezero crater in 2021, is specifically tasked with searching for signs of past life. Jezero crater was once a lake, and scientists believe that it could hold preserved signs of ancient microbial life in its sedimentary rock layers. Sample return mission. Perseverance is collecting rock and soil samples, which will be cached on Mars until a future mission can bring them back to Earth. Analyzing these samples on Earth could be one of the most important steps in determining if life ever existed on Mars. Mars 6 Mars and terraforming ideas. Terraforming. Some scientists and visionaries, including Elon Musk, have proposed terraforming Mars to make it more habitable for humans. Concepts include introducing greenhouse gases to thicken Mars' atmosphere, creating a magnetic field, or even releasing carbon dioxide stored in the polar ice caps to warm the planet. Challenges. Terraforming Mars would be an enormous challenge due to its lack of a magnetic field, thin atmosphere, and limited resources. It would likely require hundreds or even thousands of years and currently exceeds our technological capabilities. But the concept fuels interest in what the future of Mars could hold. Harbor 7. Possible Martian caves and lava tubes. Mars has many surface features resembling lava tubes and caves, which were likely formed by volcanic activity. These underground structures could provide natural protection from the harsh surface conditions, including extreme temperatures and radiation. Some scientists believe that these caves might be the best places to search for microbial life, as they could offer more stable temperatures and protection. They are also considered potential sites for human habitats, as they could offer natural shelter. 8. Current and planned missions. In addition to Perseverance and Curiosity, other missions are actively studying Mars, such as the European Space Agency's ExoMars Trace Gas Orbiter, which searches for atmospheric gases that could indicate biological or geological activity. China's Tianwen-1. China's first Mars mission, Tianwen-1, includes an orbiter, lander, and rover, Zhurong, that are investigating Mars' surface and atmosphere. Future missions. NASA, ESA, China, and other space agencies are planning new missions to further explore Mars, including potential missions to bring samples back to Earth, explore Phobos, and prepare for human exploration. NATRA 9. Human challenges on Mars. Mars presents extreme challenges for human survival due to its low gravity, thin atmosphere, high radiation levels, and scarcity of water in accessible forms. Radiation protection. Without a magnetic field and thick atmosphere, Mars is exposed to high levels of cosmic and solar radiation. Any human missions would need to rely on habitats with radiation shielding or even underground bases. Resource utilization. Technologies for in situ resource utilization, ISRU, are being developed, which would allow humans to create water, oxygen, and building materials from Mars's resources to reduce dependency on supplies from Earth. Mars continues to be a prime destination for exploration and holds a special place in humanity's imagination as the next frontier. Each mission and discovery brings us closer to understanding whether Mars was once a cradle for life or could be a second home in the future.